In this episode, Dr. Alexander Wisner-Gross, Salim Ismail, and Dave Blunden dive into the breakthrough release of GPT 5.2 from OpenAI and its staggering improvements over previous iterations. The panel explores the acceleration of AI capabilities, the looming transformation and potential collapse of traditional corporate structures by 2026, and the massive wave of layoffs already underway. Beyond AI, the discussion extends to cutting-edge developments in biotechnology, robotics, space-based infrastructures, energy, and the social and economic shifts accompanying these technological revolutions. OpenAI's launch of GPT 5.2 has created a seismic shift in AI capabilities. The model demonstrates revolutionary improvements across a variety of benchmarks, from software engineering to advanced math and visual reasoning. While previous versions showed steady incremental gains, GPT 5.2 exhibits a qualitative leap that has left experts like Dr. Alexander Wisner-Gross astounded at what can be achieved in a matter of weeks. This leap is not purely from architectural changes, but primarily due to three strategic knobs: increased compute allocation, selective relaxation of safety constraints, and extensive post-training on targeted reasoning and problem-solving benchmarks. Benchmark distinctions highlight that GPT 5.2 reaches near saturation levels on the ARC-AGI reasoning tasks, problems once seen as a defining challenge between human and machine intelligence, with efficiency improvements over 390-fold compared to earlier models. Despite these advances, Google's Gemini 3 Pro still outperforms GPT 5.2 in certain high-level math problems, underscoring the fierce and closely matched competition among frontier AI labs. One of the most concerning metrics is the GDP-Val benchmark, which quantifies the automation potential in 44 different knowledge worker occupations. GPT 5.2 achieves a performance level suggesting that more than 70% of these tasks can be performed better and substantially faster at a fraction of the cost compared to humans. The implications for the knowledge economy are profound, signaling that traditional knowledge work is becoming obsolete and triggering large-scale industry disruptions. Layoffs have surged, with 1 million workers dismissed in 2025, the highest rate since the 2020 pandemic. The reason closely ties to AI's increasing ability to outperform humans in knowledge work at speeds and costs previously unimaginable. Despite this, corporate inertia has slowed widespread AI adoption. Enterprises often wrestle with legacy programming languages like Java or C, and operational constraints, such as tightly controlled communication protocols that hinder AI integration. Experts predict a pivotal year in 2026 where the corporate world faces an existential crisis. The combination of accelerated AI capabilities and delayed implementation will lead to a cascading collapse of old business models. Early adopters who embrace AI-native architectures, scrapping legacy systems to build fresh AI-first stacks, will surge ahead competitively, while laggards risk obsolescence or forced liquidation. This organizational upheaval is not just technological, but cultural. Companies must facilitate a mindset shift throughout all levels, from CEOs to frontline employees. Many firms are caught in paralysis, relying on traditional consultants who reinforce old paths instead of fostering transformative change. The solution involves partnering with AI-native startups and reskilling programs that enable workforce transition. Universal basic income and universal basic services are discussed as likely social safety nets emerging from this disruption. The episode highlights the ongoing competitive race among hyperscaler labs, OpenAI, Google, Anthropic, and Meta. While OpenAI powers forward with GPT 5.2, Google dominates certain problem domains with Gemini 3 Pro and is exploring the deployment of TPU-based data centers in space. Anthropic carves out a 40% enterprise market share, focusing on trusted coding and AI services, whereas Meta pivots heavily toward inference time speed and multi-agent optimization to regain footing. Meta's strategic dilemma involves balancing three possible paths: commoditizing AI to drive down costs, which faltered with Llama 4, enhancing existing social media platforms with strong AI features, or pursuing closed-source frontier model supremacy. Internally, this has caused friction and uncertainty. Meta's massive $14 billion investment in AI talent and R&D underscores its commitment to winning the AI race, but also complicates strategic clarity. Regulation also enters the race. The White House's executive order to preempt patchwork state AI laws with uniform federal policy exemplifies urgent national-level governance needed to harness AI safely while maintaining global competitiveness. One of the most exciting moonshots discussed is the work by Colossal to bring back extinct species through de-extinction, using precise gene editing and DNA sequencing. Remarkably, they work with DNA samples that span from 10,000 to 1–2 million years old. The team reconstructs approximate genomes based on phenotypic traits such as hair length and tusk structure, bringing back creatures like the direwolf, woolly mammoth, and saber-toothed tiger. These programs represent a convergence of AI, genomics, and robotics, enabling unprecedented control over biological engineering. The woolly mouse, a synthetic organism resembling a mammal with woolly hair, highlights how AI-guided reconstruction can manipulate phenotypes for practical applications, such as clothing fibers. Robotics with multiple arms are envisioned to harvest such material for real-world use. The broader implication is that AI-native bioscience will drastically accelerate medicine, longevity research, material science, and sustainability efforts by creating autonomous dark labs that automate hypothesis generation and experiment validation at previously impossible speeds. Hollywood faces disruption from AI-native digital actors such as Tilly Norwood, an entirely AI-created actress whose roles and social media presence already rival human performers. With 40 contracts and tens of millions of views, AI actors pose existential challenges to conventional entertainment business models, including unions like the Screen Actors Guild. While authenticity has historically been valued, the episode argues that human audiences increasingly prioritize interest and entertainment value over real human presence. Short-form media, video games, and digital streaming platforms amplify this shift more rapidly than traditional cinema. Licensing deals, such as the partnership between OpenAI and Disney to generate classic characters in new formats, hint at an emerging hybrid marketplace of legacy IP and AI-generated content. Actors and creators in these spaces will need to adapt by licensing their digital personas to participate in this evolving ecosystem, or risk being replaced by synthetic alternatives who never age, fatigue, or demand royalties. Robotics remain a critical frontier, with particular attention to multi-armed humanoid robots capable of complex, non-humanoid tasks, such as automated shearing of woolly mouse fibers. The debate between anthropomorphic and function-optimized robot design continues, with experts predicting a Cambrian explosion of robotic formats to fit task-specific needs. Innovations from China, Europe, and US firms are rapidly advancing retail automation, exemplified by humanoid robots running convenience stores and robotic vertical farms that produce food efficiently within urban centers. Vertical farming can dramatically reduce food miles, save vast amounts of fresh water, and produce yields multiples higher than traditional agriculture. Boston Dynamics and other companies plan to scale humanoid robot production to automotive volumes within the next few years, reflecting the shift from bespoke machines to mass-manufactured intelligent labor. Meanwhile, drone technologies are evolving beyond commodity status toward immersive consumer experiences blending VR and aerial videography. The rapidly growing demand for AI compute power drives transformation in data center infrastructure worldwide. New data centers are rapidly emerging in strategic global regions such as Qatar and India, supported by sovereign investments and partnerships. Competition in chip supply is further complicated by geopolitical friction. China's push to limit access to NVIDIA's H200 GPUs despite U.S. export clearance illustrates a protectionist race to foster indigenous chip-making capabilities. This bifurcation is accelerating a second Cold War in technological infrastructure, separating U.S. and Chinese AI ecosystems. Data centers' energy supply chain faces bottlenecks too. Gas turbine manufacturing lead times have stretched to 7 years. Boom, originally a supersonic jet startup, pivoted successfully to manufacturing supersonic gas turbines customized for AI data centers, securing a $125 billion backlog. Their strategic shift exemplifies adjacent industry pivots within AI's ecosystem. Nuclear energy also features in the energy discussion, with China dramatically undercutting U.S. nuclear power costs due to streamlined permitting and centralized policy, versus the U.S. patchwork of regulations and state-level opposition. Advancements in AI and institutional reputations, such as MIT's exothermic nuclear reactor project, signal renewed momentum for nuclear as a foundational power source. The ambitious vision of shifting data centers into space is no longer science fiction. Google's plans to deploy TPU-powered data centers on satellites underline attempts to capitalize on unlimited solar energy and eliminate terrestrial cooling limitations. These orbital data centers leverage radiative cooling by directing heat into deep space, making them energy efficient despite earlier skepticism. Space poses unique challenges, including fault tolerance against solar storms and EMP, constant disruptions, and a need for redundancy through wide distribution across orbits. The ephemeral 3-year replacement life cycle for satellite data centers contrasts with decades-long terrestrial data center lifespans and demands rapid manufacturing and launch capabilities. Crowded orbits and the lack of clear geopolitical governance of low Earth orbit add complexity. Nonetheless, the strategy aligns with the long-term goal of building Dyson swarms and harvesting the sun's energy on an unprecedented scale. AI is already saving workers significant time. Studies show an average of 40 to 60 minutes per day through automation of monotonous tasks. However, these gains come with job displacement. The panelists emphasize not only reskilling programs to handle workforce transitions, but also the need for cultural and mindset changes within companies to embrace AI's transformations fully. The political dimension includes the federal government's consolidation of AI regulatory authority to prevent fragmentation at state levels. This preemptive federal move aims to balance innovation with safety and maintain U.S. competitiveness. Conversations about Universal Basic Income, UBI, or Universal Basic Services, UBS, emerge as inevitable social responses to widespread automation. The panelists propose these will be rolled out through experiments and pilot programs with urgency, given the speed of AI disruption. Hardware innovation continues with projects like the Pebble Smart Ring, a minimalistic wearable device focused solely on capturing voice memos and reminders to interface seamlessly with on-device large language models. This augments human cognition unobtrusively. Discussions speculate on the near future of ingestible, injectable, or implantable AI platforms enabling continuous, low-latency interaction with foundational models. Proposals include subdermal microphones and speakers placed behind the ear, enabling an ever-present AI interface integrated with the human body through biocompatible hardware. Several other highlights include the rise of robotic vertical farms in cities to reduce food supply chain inefficiencies and increase sustainability. The vision of humanoid robots operating retail outlets points to automation pervasiveness in daily life. Additionally, AI-driven material science and autonomous laboratories promise to revolutionize scientific discovery, with ventures from Google DeepMind and others establishing dark labs that automate experimentation faster than human researchers. The episode concludes with a creative touch, a communal drinking game bingo card inspired by recurring podcast themes symbolizing the culture of exploring radical ideas and moonshots in tech.